So here we have g of x is x plus 6 divided by x squared plus 2 raised to the third power. We want to determine g prime of x by using the chain rule. That's our main idea here. So we have something to the third power. So let's consider that g of x equals this whole thing to the third power. So g prime of x is the derivative of this whole thing to the third power. And of course, we know our power rule, right? The derivative with respect to x of x to the n is nx to the n minus 1. So the derivative of something to the third power would be 3 times the something to the second power times the derivative of the something. Now, what is the something here? The something here is x plus 6 over x squared plus 2, right? X plus 6 over x squared plus 2. That's what we want the derivative of that. We want the derivative of x plus 6 over x squared plus 2 to the third power. So that'll be 3 times x plus 6 over x squared plus 2 to the second power times the derivative of x plus 6 over x squared plus 2. And that is going to require us to use what? That's going to require us to use the quotient rule. So let's leave this aside for a minute. G prime of x is 3 times x plus 6 over x plus 2 squared times, and this next piece we will do using the quotient rule. And moving to a different piece of paper. What do I want? I want the derivative with respect to x of x plus 6 over x squared plus 2. I need a u, I need a v. U is x plus 6, v is x squared plus 2. U prime, the derivative of x plus 6 is just 1. V prime, the derivative of x squared plus 2 is 2x. What is our rule? Remember, u over v prime is u prime v minus uv prime over v squared. Keeping all that in mind, then, let's go ahead and do this analysis. Derivative with respect to x of x plus 6. U prime v, 1 times x squared plus 2 minus uv prime minus x plus 6 times 2x, all divided by v squared. What is v squared? X squared plus 2 squared. What is this going to give us then? Derivative with respect to x plus 6 is what? X squared plus 2 is this first piece. Minus, be careful with our distribution here, 2x times x, 2x squared, 2x times 6 is plus 12x over x squared plus 2 squared. Where does that leave us? Distributing the minus sign on top, we have, that's 1x squared if you like, plus 2 minus 2x squared minus 12x over x squared plus 2 squared. 1x squared minus 2x squared, that's negative x squared minus 12x plus 2 all over x squared plus 2 squared. That is the derivative of the inside function. So we've done that. So remember, this was our original page. Let's rebuild it one more time. I wanted the derivative of this thing to the third power. Using the power rule, 3 times this thing to the second power times the derivative of this thing. And we just did the derivative of this thing. The derivative of this thing turned out to be this, right? Negative x squared minus 12x plus 2. Negative x squared minus 12x plus 2 over x squared plus 2 squared. Now, I'm not a stickler on simplifying these things. So we're not going to spend a whole lot of time simplifying it, but I'm going to spend a little bit of time simplifying it, just to make it easier for me to check on Desmos. So what do we have here for our g prime of x? What do we have here? G prime of x upstairs, 3, x plus 6 squared. Downstairs, x squared plus 2 squared. Upstairs, negative x squared minus 12x plus 2. Downstairs, x squared plus 2 squared. So we can just make this a little bit simpler by taking x squared plus 2 squared times another x squared plus 2 squared to give me x squared plus 2 to the 4th power. So a somewhat simpler version of this, g prime of x is going to equal 3 times x plus 6 squared times negative x squared minus 12x plus 2 divided by x squared plus 2 squared times another x squared plus 2 squared, which gives me x squared plus 2 to the 4th power. So this is what I believe the answer was. My original question way back when was this. Was x plus 6 over x squared plus 2 to the 3rd power. I would like to check this on Desmos. What are we going to remember? What are we going to remember? G of x plus h minus g of x over h is approximately equal to g prime of x when h is small and the function is differentiable. So I'm going to use an h of 0.001. That's my preferred way to do this, to go ahead and check my work as we're going along here. So let us do that. To Desmos we go. My original function, g of x, was x plus 6 divided by x squared plus 2 all to the 3rd power. So a little tricky to do this. Let me do it this way. X plus 6 divided by x squared plus 2. And that whole thing is raised to the 3rd power. To the 3rd power. Okay. So that's my graph of g of x, but I don't really care so much about the graph of g of x. I'm going to turn that off. What I care about is its derivative, which I'll call p of x. G of x plus a small number minus g of x over that small number. G of x plus 0.001 minus g of x divided by 0.001. And this is what I believe the derivative looks like. Now, I expect this is probably noise. When you see these kind of vertical asymptotes on Desmos, that's usually some kind of an error. I could go with a smaller h if you want and see if it changes much. But sometimes we have big problems when that happens, but you can see we have the same kind of graph. So I'm happy enough with 0.01. I want to see, is that the same graph that I think I get when I take the derivative? So let's turn off this blue graph. Let's remind ourselves of what the derivative function we hope to be. 3 times x plus 6 squared times negative x squared minus 12x plus 2 over x squared plus 2 to the 4th power. That's what we hope the derivative function is that we are checking. So let's take a look at it. And we call that one P, call this one Q, I guess. What's upstairs? 3 x plus 6 squared negative x squared minus 12x plus 2. This is all upstairs. Divided by, what do I have downstairs? X squared plus 4, x squared plus 2 to the 4th power x squared plus 2 to the fourth power. Do they look like the same functions? So this is the one that I believe is correct by using the chain rule and the quotient rule. This is the one that I get for p of x. Are they the same? They do not appear to be the same. So I guess I need to do this video over again. Unless I can find an error. Oh, I think I found my error. I miscopied this. How about make this a 2 instead of a 12? Let's make sure we're clear. So we'll go back and look again. This is what it should have been. 3 times x plus 6 squared times negative x squared minus 12x plus 2 over x squared plus 2 to the fourth. So incorrect typing skills is what burned me there. So let's go back to Desmos. Now, here we go. Here is what I received by using a small h. And this is checking my work using the formulas. Does the green function match the blue function? Sure, it looks like it does. So I guess I don't have to do this video over again. I think we have agreement.